Hello, and welcome to our lesson on negative and fractional enlargements. Today, we will explore some intriguing concepts that will significantly deepen your understanding of transformations and scaling in geometry. In this lesson, we'll build on your existing knowledge and introduce two new types of enlargements: negative enlargements and fractional enlargements. Specifically, we will understand the concepts of negative enlargements and what they entail, learn about fractional enlargements and how they differ from whole number enlargements, develop the skills to draw and interpret these transformations, and after gaining this foundational knowledge, we will practice applying these concepts through some examples. In our previous lessons, we've built a solid foundation by discussing enlargement using positive scale factors. You are now familiar with the idea that an enlargement changes the size of a shape by a certain scale factor, where the length of each side of the shape is multiplied by the same positive number. With this foundation, we are now ready to delve deeper and explore negative and fractional enlargements. Negative enlargements are particularly useful as they help us understand reflections combined with scaling, giving a mirrored and resized image of the original shape. Fractional enlargements, on the other hand, help us accurately scale down shapes, which is critical in situations like creating scale models or working on detailed drawings. For example, imagine you're tasked with creating a scaled-down version of a large blueprint. Understanding fractional enlargements allows you to accurately reproduce the shape at a smaller, manageable size while maintaining its proportions. Similarly, if you need to represent a reflection of an object that is also resized, negative enlargements come into play. Let's get started and unlock these new mathematical tools together. Recall that enlargement is a transformation that changes the size of a figure by a scale factor, while maintaining its shape and the proportionality of its sides. A negative enlargement flips the figure over the center of enlargement and scales it by the absolute value of the scale factor. A negative scale factor indicates both a flip and a scale change. For example, a scale factor of -2 means the figure is enlarged by a factor of 2 and flipped over the center. For example, if a triangle with vertices at 1, 1, 2, 1 and 1, 2 is enlarged by a scale factor of -2 from the origin, the new vertices will be at -2, -2, -4, -2 and -2, -4. Remember from our previous lesson that when enlarging about the origin, we simply multiply the coordinates of each point by the scale factor. This still works for negative and fractional enlargements. Drawing negative enlargements is a very similar process to drawing positive enlargements. You start by labeling the center of enlargement and drawing a line through it to each of the vertices of the shape being transformed. Next, measure the distance from the center of enlargement to each vertex horizontally and vertically. Multiply this distance by the absolute value of the scale factor, flip the direction, and mark the new points. Finally, connect the enlarged points to form the enlarged and flipped figure. Let's now move on to fractional enlargements. A fractional enlargement is an enlargement by a scale factor between 0 and 1. It reduces the size of the figure by the fractional scale factor while maintaining the proportionality of its sides. For example, a scale factor of 0.5 halves the size of the figure. If a square with vertices at 2, 2, 4, 2, 2, 4 and 4, 4 is enlarged by a scale factor of 0.5 from the origin, the new vertices will be at 1, 1, 2, 1, 1, 2 and 2, 2. Let's go through how to draw a fractional enlargement. Once again, label the center of enlargement and draw lines from it through each vertex of the shape being transformed. Measure the horizontal and vertical distances from the center of enlargement to each vertex. Multiply this distance by the fractional scale factor and mark the new points. Finally, join the new points to form the reduced figure. Let's do some practice problems. We'll start with a straightforward example of negative enlargement. Imagine you have a triangle ABC and you want to enlarge it by a scale factor of -2 about the origin. Let's say the center of enlargement is point O, which is outside the triangle. We start by drawing lines from O through each vertex of triangle ABC. These lines will help us locate the new vertices of the enlarged triangle. Now measure the distance from O to each vertex of the original triangle. For example, we can see that point A is 4 units above and 2 units to the right from point O. Point B is 2 units above and 4 units across, and point C is 4 units above and 4 units across. Since the scale factor is negative in our case, we will extend the line in the opposite direction from O. Now we locate the new points, A prime, B prime, and C prime. Recall that our scale factor is -2. For A prime, we go 8 units below and 4 units to the left from O. For B prime, we go 4 units below and 8 units to the left from O. For C prime, we go 8 units below and 8 units to the left from O. Finally, connect points A prime, B prime, and C prime to form the enlarged triangle. Now let's look at a fractional enlargement. Suppose we have a rectangle PQRS and we need to enlarge it by a scale factor of 1/2 with the center of enlargement at point O. Once again, start by drawing lines through O to each of the vertices. Now measure the horizontal and vertical distance from O to each vertex. Halve those distances to get the vertices of the transformed shape, P prime, Q prime, R prime, and S prime. Finally, draw lines to connect P prime, Q prime, R prime, and S prime, forming the smaller rectangle. For a more complex example, let's consider enlarging an irregular pentagon by a scale factor of -1/3. The center of enlargement is point O inside the original pentagon. Once again, we start by drawing lines from O through each vertex of the pentagon. Since the scale factor is negative, we continue our lines in the other direction. Now measure the distance from O to each vertex. Our scale factor is -1/3, so we multiply each distance by 1/3 and move that distance in the opposite direction from O to get the transformed vertex. Finish off by connecting all the new vertices to form the enlarged pentagon. These examples illustrate how to handle negative and fractional enlargements. By consistently applying the steps, you can tackle a variety of shapes and scale factors. In today's lesson, we explored the concepts of negative and fractional enlargements, focusing on what they involve and how to draw them. We began by recapping what an enlargement is in geometry, transforming a shape by a scale factor, which changes the size but not the shape. We then delved into negative enlargements, where the scale factor is a negative number. This not only changes the size of the shape, but also reflects it across the center of enlargement, effectively flipping the shape. Next, we examined fractional enlargements, where the scale factor is a fraction less than 1. This reduces the size of the shape while maintaining its proportions. We discussed how to draw both types of enlargements, emphasizing the importance of accurately determining the center of enlargement and applying the scale factor correctly to each vertex of the shape. We also worked through several examples to solidify these concepts, drawing both negative and fractional enlargements and observing the resulting transformations. By understanding and practicing these techniques, you can apply these concepts to solve various geometric problems, making them essential tools in your mathematical toolkit.